Hey, my name is Cristian, and one thing I wanted to say before starting is that this is my first presentation. I did a couple of times before, but it's still my first. So I'm really sorry for what is about to happen. um, uh, One thing that I learned, I mean, it's my first time I do this presentation, but I've been going to conferences for 12 years now. So I've seen all the big ones. I've seen Mats, I've seen DHH, I've seen Aaron Patterson, Eileen, who is my favorite. So I've learned a few techniques, and one thing I always like it is when the presenter introduces you the whole concept in the first two slides. So then you can already leave, and that's okay. So this is my first slide. This is a very well-known issue in Twitter. Everybody knows. I think these days in computer science class is the first thing they tell you. Rails doesn't scale. Who agrees with this universal truth here? Okay. No one. You destroyed my joke. Okay. So this will be my second slide. This is not true. Rails scales. And I say that Rails scales because there are companies using it at scale. I work at Zendesk. If you see the title, it says 1 billion requests per day. That's actually not true. It's 2 billion requests per day. I just put one because it sounds nicer. But here you have a tweet from last year saying that the Rails app, the Rails monolith at Shopify, returns 4.3 petabytes in one day. Actually, I think the next slide is even better. They serve 76 million requests per minute, and that's 127 million requests per second. That's scaling. Before we go into the topic, I want to introduce myself a little bit more. I'm originally from Barcelona. I work at Zendesk. I've been there almost 10 years. I'm currently group tech lead. I specialize right now in performance issues. I do a little bit of everything, but performance is like my passion in regard. Actually, I just came back to Europe. I was 7 years in the US. And actually, there I had the opportunity of presenting this presentation. This is like an iteration of the same one at RailsConf. However, this is like a special occasion for me. It's the first time I speak in Europe. I'm very excited. Moreover, I'm very happy that this happens in Poland, because my first Ruby conference ever was here in Poland. Was actually in Poznan. Was a very, very peculiar conference called Ruby. Yes, it was a mixed Ruby and Python conference, like dynamic language festival. And actually, one talk there is one talk that I think very, very often. I don't know if you know who is this guy. Anybody? Yeah, Jose Valim. So at that time, in 2011, Jose Valim. Jose Valim, sir. Okay. Sorry. He was very famous at the time as a Rubyist. But his presentation was not about Ruby. It was about designing a new language. It was very, very cool for me because you study computer science, we have this subject called compilers, which basically you learn how to design a language. Eventually, in that same year, he released Elixir, which was probably maybe the most important language of the last 15 years, or at least in the conversation, I would say. That was a great talk. I'm pretty sure that this talk is not going to be that memorable, unfortunately. But I hope you're going to take something out of it, because this is an important topic. Why I'm talking about it? Well, again, I want to reiterate that some companies are using Rails at scale, but over and over and over, this topic comes back. In the last few weeks, Programming Twitter was talking about this again. I don't know if you've been following the latest drama in the Ruby community. I don't know if you're familiar with this tweet. It's actually, I find this a bit funny, like how we are in the Ruby community. We have this yin and yang celebrities. We have Mats, who is the creator of Ruby, who's like the nicest, sweetest person ever. And then we have DHH, who writes things like, basically, DHH removed TypeScript from, I believe, Basecamp. And he not only did that, but he made it in a very public way. And I will read. Let the rest of us enjoy JavaScript in the glorious spirit it was originally designed, free of strong typing. So when you do this happens. You get a flame war with people attacking them and attacking everyone and trolling in general. So much that someone decided to make a PR in Basecamp putting back TypeScript. So obviously, because DHH is the creator of Rails, people started to attack Rails. And DHH made this post putting some companies that use or used at some point Rails, which is true. And in between all this trolling and flame war, there was a few compelling debates. Like, for example, this conversation here, where some people say, hey, Shopify is scaling, why Twitter couldn't? And there's a good point. I mean, it's a very different use case, but in the end, it's a good point. Shopify lends itself to horizontal scale much more than Twitter does. That was interesting. And more in general, there's this other point that Rails allows you to pivot very, very fast. For a startup, this is incredible. Even I, that I am a Ruby person, I don't know if I would write a microservice in Ruby, except sometimes I do, but it needs to be in some special cases. Again, it's an interesting discussion. My personal take on this would be something like monolithic architectures have significant drawbacks when operating at a planetary scale, which is it's like a pretty good point, I would say. But even this, some people would debate. Like, for example, GitLab. They wrote 1 year ago this article about why they're sticking with Ruby on Rails. And their point for me was quite unexpected. Their point is that structuring GitLab as a monolith has been extremely beneficial for us. So they believe in Rails because of the monolith structure. That's interesting. Again, it's an interesting discussion. It's a good discussion. I would just appreciate if people can have a discussion in a civilized way. I'm not dealing in absolutes. That's for me a show that not great engineering when someone says this technology is bad. It's a bit childish in my opinion. But in any case, I think that the maximalist position that Rails doesn't scale is just not true. Because again, some people are using at the scale. So arrived at this point, I'm always wondering why we got to this situation. Why is people saying all the time Rails doesn't scale, Rails doesn't scale? Actually, I found this tweet in this flame war about saying every programming community has some deep-seated insecurity they seemingly never get over. And it's actually true. I mean, it's true that Ruby is not incredibly performant, but there are other languages that are maybe a bit faster than Ruby, but are in the same ballpark, in my opinion. And you never get into this unending conversation. So why is this happening? And I have a theory. But for this, you will need to time travel a little bit with me. By the way, this is Doraemon. He's a robotic cat. He will come back later in the presentation. So yeah, we're going to travel to the year 2010. This is me in college. And I was writing my first Rails app. And I wanted to have authentication. Authentication is a hard problem. From encryption, well, it's pretty complicated, believe me. So then, and I had no idea. I was still in college. I was just wanting to have like a nice magazine for me to write stuff. It was just for fun. So then, of course, I did like a deep thought investigation. I talked with the experts in the field, blah blah, and I found this nice gem called Device, which I'm sure is by Jose, I think. And well, I just read the documentation and I installed it. It just worked. Authentication is a hard problem. Later, I actually became authentication and security tech lead at Zendesk. And, there are a lot of quirks. And the worst of all is that if you do something wrong, it has very bad consequences. But for 20-year-old me, it didn't feel like that. It felt like, hey, this is so easy. My next point is you need to travel in time again with me and move to year 2012. I was CTO. I was also the only engineer, to be honest, on this startup. And the startup was very, very popular. Like, we had a lot of traffic. And it was a Rails monolith. I had to make it scale. Scaling is a hard problem. So again, I did a very, very long investigation. And I found this fantastic gem called ActiveScale. I hope you know it. I read the documentation. I use the parameter sufficient but not too much. And that's it. Everything was beautiful and nothing hard. Incredible. Thank you. Okay, that's not true, obviously. I wonder if I did this presentation 3 times. I was wondering if someone searches for active scale. Active scale doesn't exist. I just modified the title of active record using Chrome tools. The issue of my point here is that scaling is a hard problem. But it's a problem that feels hard. There is not a free lunch that you can, I'm going to download this gem and everything is done for me and that's it. This only is very useful when you're a junior engineer in Rails. And I think it's probably one of the reasons why Rails is so popular. But scaling is one of those problems that you cannot do this. So my final point is not that Rails doesn't scale. Is that Rails is so good that one of the few problems for you to solve is scaling it. The Rails learning curve is so smooth that when you finally hit a point that not everything is solved for you, it may feel impossible. Okay, now finally we're going to discuss techniques. But before that, I want to give some general concerns. The purpose of this talk is an introduction to the problem of scaling. We're going to discuss general ideas illustrated with issues we face scaling to a significant degree. Very important, you need to understand that there are no silver bullets. As Tolstoy kind of said, every poorly performing system is performing poorly on its own way. When sometimes I have discussions of, this application doesn't scale, and how to fix it? Well, I don't know. Most typically, tends to be problems with database queries, indexes, stuff, but sometimes can be completely different ways. Next is the sense of the problem that we work at Zendesk. Zendesk is a customer support platform. So basically, we manage tickets. We have currently over 20 billion tickets in the system. That's more or less that you could give to each person on the planet like 2.5 tickets, and that would be it. Moreover, there is a lot of growth. Around 32% of the dataset is new of the last year. This has obvious consequences in our systems. The relational database alone, and we have other databases like Dynamo, is over 400 terabytes. Moreover, we have a beautiful pretty table, which I have a lot of love, and actually kind of the owner at this point, which for multiple reasons in some charts have trillions of objects. Let's say that DBA and I talk about this often. So it's a complex issue. The problem is big, let's say. Finally, before going to the techniques, I would like to talk about having fun with these kind of problems. I think that for a lot of engineers, they feel that performance work is kind of a drag, that they should be building features instead, and it's something that I do just to fix and move the problem along. I think that the right mindset here is to get this. The try needs to be getting things like that. This is a real optimization with it, using caching, I think. And we moved an endpoint that sometimes it was hitting 1 second, to under 100 milliseconds. When you get something like this, you feel like that. It's fantastic, honestly. Okay. The first thing I wanted to discuss here is monitoring and error budgets. This is maybe the most important thing you can do. Why? Because you cannot fix a problem you don't know you have. First, monitoring. There is multiple levels of monitoring. You obviously have logs most of the time, APMs to trace the request, and metrics. Monitoring can be expensive, particularly at scale. But with performance, I always say that there is an issue that sometimes is forgotten. Sometimes I'm worried that people put metrics and logs in the same box, but they are different. Logs are very useful because you want to trace what exactly happened with this specific request at this specific point in time. With performance, it's a bit different. With performance, you can sample a lot. Maybe sometimes we sample like, I don't know, only 10% of the data for certain purposes again, and this works good enough to understand the performance of our logic. The natural evolution of this, I said, is what we call error budgets. You can set an error budget for latency in an endpoint. For example, this is a real example that we have at Zendesk. This is for ticketing. We defined 3 very important endpoints for us: ticket show, ticket create, and ticket update. And if you check in the left column, we have uptime. I think it's obvious. But then we define latency acceptable times. We defined, I don't remember now the exact numbers, but for ticket show, maybe it's 1 second because it's a slow endpoint. Or I think it's less, but well. We define an arbitrary time, which is acceptable for us, and that endpoint needs to be in the acceptable amount of time, 99.95% of the time. and it's to be in a good amount of time, maybe, I don't know, 300 milliseconds in 96.5. This is very important. And maybe you're thinking, well, you are literally defining a completely arbitrary number here. That is true, but you need to have a North Star. It cannot be that an endpoint degrades completely 500 milliseconds and nobody realizes. Moreover, the final evolution of this is setting error budgets for specific parts of the logic. A lot of times you will find that you have a module that is invoked by multiple processes, by multiple endpoints. It can be a good idea to set a particular error budget for this part of the code. Next is the part that everybody thinks that is the star. And being honest, when you're working with performance and fine-tuning performance, this is the most important. However, I don't really want to talk that much about it. The original title of this talk was Beyond N+1, because I think there is plenty of resources about that already. Still, I will say some kind of obvious things. Use database indexes. That's kind of obvious, again, but you'll be surprised. Sometimes, particularly in big companies, the responsibility of establishing a database index falls in some point in between DBA and engineers. So be conscious about that. One thing I noticed, particularly when working with very big tables, is that do not assume that your database engine will pick the right index. A lot of times, it doesn't. And actually, another issue that I don't know if I've ever commented in this presentation is that in very, very big tables, the index can be very big itself. I think we have this table I commented before that has trillions of objects. It's an extremely small table, as like each object is very, very small. And actually, I think that the indexes are bigger than the data itself. That's another thing to take into account. Next, and actually this goes to what we were discussing before about Twitter architecture versus Shopify architecture, is sharding. The idea of sharding is that can you divide your data into independent databases? For example, Shopify. You have an account of a Shopify account. You don't want to query what is in another account, hopefully. This ends up with you having a centralized database that is shared across all the hosts. Like, for example, the account table of Shopify probably is centralized and all hosts can access. But then each shard has data for each specific customer. Next is an anti-pattern that is incredibly common in Rails, thanks to Active Record. It's what I call greedy selects. So when you do a query, like for example, user where ID bigger than 42, you're going to fetch all the columns. This sometimes is okay, and again, Rails is very junior friendly and it works. But what happens when you are going to, I don't know, print all the IDs for a table, and the table happens to have 10 blobs and 20 columns of text? You will end up with a lot of stuff that you really don't need. This is something that we found at Zendesk when we had a lean endpoint that returned only the ID and title of certain objects, and that object was an incredibly complex group of rules, basically. Just adding a .select ID and title made this on our performance of a very important endpoint. Finally, I want you to remember that complex database queries have very high variability. This means that a lot of times when we check the performance of a query, we check, hey, this typically takes this time, like the median, the P50. That's not good enough. Your North Star should be P99. Because P99 is the one that causes problems in the databases, causes meltdowns, really. Please check that. On the direction of how to improve performance, you have caching. Caching, as you know, is the practice of putting part of the data in a smaller, faster data storage so you can access it faster. One thing that works very well at Zendesk is write-through caching, particularly when we're using denormalized objects. So, for example, you have a side load that invokes, I don't know, the sum of multiple objects. You don't want to be calculating this all the time on the read. What you can do is do it on the write. On the write, maybe you can do this asynchronous. We'll talk about this later. But if you do it on the write, obviously the read is immediate, be way, way, way faster. This actually happened again at Zendesk. We had this side load that was making some pretty complex calculations. And we decided this is too much. Let's do it asynchronously and on the right. And again, we cut from something that was taking 40 milliseconds, only the invocation of that sideload, to less than 10. And you may be thinking, well, 40 milliseconds is not a lot. But again, at scale, small changes are very big. That endpoint, I checked this data in 2021, no, 2022, I think. But it was being, sorry, that sideload was being invoked 50,000 times per day. Multiplied by 365 days, we're talking about more than 8 full days of computing time per year, which is significant. Again, trade-offs about caching. You're adding complexity. You're adding a new source of truth. Well, caching is not the source of truth, but it's the source of when you do the reads. So you may start having data that is not consistent. It's complex. And moreover, caching isn't trivial. It's not just adding a new layer of memory and everything goes well. And with this, finally, we go back to what I told we would go back. Doraemon. Does people know Doraemon here? Okay, yeah, okay. It's very popular in Spain. So it's a Japanese anime, which basically is about a robotic cat from the 22nd century, which has millions of futuristic gadgets in his 4D pocket. So basically, he's almost a wizard, a robotic wizard. He has this crazy pocket where everything fits and nothing makes sense, you know, like you can put whatever. It's a bit like Redis. Yeah. Yeah, so I discovered by thinking about it that Doraemon is kind of an incredible fable about software engineering, and particularly about more junior engineers, how they behave with technology. The thing is that Doraemon, each and every episode has exactly the same structure. So Doraemon, he lives in, for some reason I don't remember, he lives in a Japanese household in late 20th century, and he lives with Nobita, who is this, I think, 10-year-old kid who is kind of clumsy and also always getting into problems. And each episode, Nobita has a new problem. Like, I don't know, I failed an exam, all kind of stuff. And he asks for help from the magic robotic cat. Doraemon doesn't want, but eventually he concedes and gives him some magical machine that fixes all the problems. And that lasts like for 2 minutes in the episode. Because eventually Nobita thinks, oh, I could use this in that way. And in that way, Doraemon told me not to, but it would work. It doesn't. And all the episodes of Doraemon end up with Nobita crying. I think maybe there's a couple of exceptions, but honestly, all are the same. This reminds me a lot of how we use technologies, particularly the ones that look very simple, like, hey, I added caching. Wow, I can use everything here. I can put everything here. I added Redis. Let's put whatever here. My point is use technology wisely. And also I would say this is very common for ORMs, for example. ORMs are fantastic. There is people that have they're very strongly opinionated against using ORMs at all. I think that happiness is important, developer happiness is important, and not having to write SQL every day makes me way happier. But at the same time, you need to have an understanding of what happens in the database when you do a query using Active Record. The next part is managing the life of your data. And this seems like a bit arcane, like why I care what happens with the data once I write it, why I cannot stay there forever. Well, the reason that you need to care is that eventually you may end up with a lot of data. Again, 20 billion tickets and one table with trillions of rows. This is problematic. For example, this table that has trillions of rows is what we call a log table. Adding new columns is forbidden. Running a backfill is impossible. Well, actually, I'm trying to run a backfill. I'm having to write a new backfiller just to run a backfill on that table. So it can be hard. A few techniques to change this to work on this data life workflow. One is the data aggregation. For example, once an interaction is concluded, do you still need all that data? Imagine there is an order. A customer has made an order in Amazon or whatever. You have a series of data that has been generated during this process. Do you still need all of it? And particularly, do you still need it in the same form as it is? Maybe you can summarize all those objects that have been created in the process in a different format. Or maybe you can even send it to a different storage. And actually, this is what we're going to discuss next, what we call cold storage. What if I told you I can literally make all that data disappear that is clogging your queries? why not send part of the data to a different storage? The idea here is that sending data that is rarely accessed to a different place, to remove it from the relational database. Let me give you an example. This is real. This is what we do at Zendesk. I made like a mini Zendesk here with a user that has many tickets and a ticket that has many events. After some time, we mark this data as ready for archival. At Zendesk, the default policy is 5 months, 150 days. When you close a ticket, this ticket is archived. An archival means that we go to the table, we go to our MySQL, and we really remove, like hard delete, the ticket and the event. But we keep that data, don't worry. We just send it to a specialized data storage, which is a key value store, or key value-ish sometimes. Historically, we use React. Now we're using Dynamo since last few years. This can be a little bit complicated because you may lose a lot of associations. So what we do instead is we create a new object called archive ticket. That is a very, very lean version of the original ticket. We basically keep there the associations. And then that archive ticket has, well, obviously points to the old ticket. So on the case of need, we can read the data or even rehighlight the ticket and get the completely functional ticket back. This is maybe the most important decision we ever took, apart from sharding maybe, for making Zendesk scale. Most of the tickets that we have are archived. They don't live in MySQL, they live in Dynamo. With the cold storage, we'll have 9 times more data, more or less. Of course, this has trade-offs, and it's a bit similar trade-offs with caching. I sort of think it's like this is like the opposite of caching. You know, caching is for hot data. This is for very cold data. Unlike in caching, you have multiple sources of data that may introduce issues to the product. Moreover, this can get a bit more complicated because in caching you're supposed to have very limited amount. Here, you literally have most of your data in many cases. One thing that you may consider, and talking with product, is changing the access patterns. Saying that, hey, archive data, very old data, won't be accessed by your typical APIs, won't be visible in your typical UI, will have a different way to access it. And with this, we go to one of my favorite parts of this presentation, that is designing a product around performance. And if there's people that work often with product, there is one principle that is super important here, that is product limits. Product limits forever, always, in all cases. The thing is that you have, when you are thinking about your platform, about your software, you may be thinking that, hey, I really understand all the use cases. Believe me, you don't. Sometimes, first of all, there is abuse, and please take that into account, that there's people that will try to abuse the platform in ways that you don't want. But moreover, sometimes you have very paying customers that just find ways to break whatever you have in the system. For example, at Zendesk, we have a data analytics platform that allows customers to fetch data in different ways and run their queries once a day. One customer managed to write a query that the query itself is 1 megabyte. I don't mean the return. I mean the text of the query. That's a killer query, literally. Again, problems may not be sexy, but remember that you always have a product limit. The reason of this is that our systems are not just text that that exists in Beam or whatever. They run on the physical world, and the physical world has limits. So this is eventually the problem you will find. Eventually, the queries will just start failing and not working. What I always recommend, even for people or for products that don't want to have a limit, is just put a crazy limit. You believe that most of users will have 10 of this object, put 500. Eventually, you will be very thankful that you did that. At Zendesk, we have this. We had to grandfather accounts into very, very high limits because eventually, originally, we didn't put any. And customers found ways to use the product that we didn't expect, and it became very complicated to manage them. The next point is what I call the incredibly enlarging payload. I think people that have worked long in the same system have seen this case. The idea is endpoints that return way too much data. So day one of a new endpoint, each object returns very limited things, no? Like users, ID, email, name, fantastic. But then slowly, I think it's called a feature creep up, I think it's called. Each team comes to an endpoint, I need this data, I need the address, I need whatever. And eventually you end up with this crazy API. Oops. Wait. Yeah. With this crazy API that returns a lot of stuff. The endpoint is very slow. It's very, very complex. And you're just sending way too much data around. Like it's hard to parse the JSON. If originally you were returning, I don't know, 500 objects, and JSON was you were able to parse it very, very fast. Now the object multiplied the size by 20, and it's just slower. It's making the front end application slower. Solutions for this is trying to divide that data. For example, you can use sideloads, you can use GraphQL. And finally, one other thing I recommend is try to breaking down slow workflows, both in the read and on the write. On the read may seem like a bad idea. Like, why I would make two requests to fetch data when I can have one? I mean, it's going to be, obviously, I'm going to execute the same logic, exactly the same one, and I'm just going to add all the time in the network. I'm going to add all the time of crossing the middleware. Seems just like a bad idea. It's literally slower. The reason for doing this is that is user experience. A lot of times, if you have another product has two levels of data. One that is the necessary for users to interact with the product, and another is nice to have. You can divide this in two. You can have some basic information about, for example, a product if you're selling things, and then the suggestions of other things to buy. That's not necessary for them to buy, so you can do it after. You can stop blocking the user. Another thing, and this one goes very, very complex, is breaking down the writes. This, again, this is another example of feature creep up. You have an endpoint that writes stuff, and originally just did write A, but then it starts to write the derivative data, more and more derivative data to multiple storages. It's just way slow. The solution for this is doing it asynchronous. You just write the basic data, and all the other writes happen later. The most common way of doing this is in the Rails world is via Sidekick, via background jobs. But more and more, well, actually later we're going to have a session on event-centered architecture. This is very common too. It's becoming more and more popular. You end up with distributed systems. One thing to take into account here is that eventual consistency can be painful. It's hard to get used of it, but it can make out of sense. One thing that we experienced at Zendesk is that particular product was sometimes very hesitant because they expected customers to feel strange. Oh, I updated this and it took a few seconds. In our experience, as long as the update happens we're talking single unit seconds, again, it depends a lot of the use case. Nobody even realizes in a lot of cases. Be more trustful of reasonable decisions. And well, we are slowly getting to the end. This is what I call special interventions. And actually, this may be my favorite part of the job. This is a bit like following the philosophy of Pographa of doing things that don't scale. What I mean is that you'll find that particularly in B2Bs, I think this is very common, that a small amount of customers may have a disproportionate impact on your SLOs. More and more, when I work at Zendesk, I end up working with the same accounts that are the ones that are of our peer customers that are the one challenging our platform. And that's actually very fascinating for me. I feel like it, like capturing a hub from Moby Dick, hunting the big white whale. It's actually a very fascinating problem. And for this, again, going back to the quote in the beginning, like each problem, each way of scaling is very different. One thing that we did is a very unexpected solution we found for one very big customer was splitting the accounts. They were putting into one account incredibly different use cases, and their use cases they didn't need them to share much. So what we did is we created a centralized account for them to share some very basic data. We manually wrote some pipelines for the sub accounts to fetch from the main account, and then eventually we just split the accounts, more or less in two. Well, less than two, but you see that the red account, the blue, the part in the middle doesn't count because that wasn't in vacations. But you see, we reduced the peak usage by a significant amount. Okay, so I'm getting to the end. I wanted to comment a few things, like more in general of philosophy. One thing I think is important is the mindset of a performance engineer, or I would call it even the mindset of a very senior engineer. You just need to be like Alexander the Great. Easy thing. On this, I'll explain a fable story about Alexander in the year 333 before Christ. He was in the town of Gordion, that's central Turkey. I don't know if you know this story, but I think it's very interesting. Basically, there was a legend there that whoever was able to untie the Gordian knot would become the king of Asia. The Gordian knot was incredibly complicated, a knot that was established by one of the first kings of Gordion. Obviously, Alexander wanted to be the king of all Asia, and he tried to untie the knot. He was not able. He spent hours. Eventually, he took out his sword and cut it. I think a lot about this when thinking about software engineering in general, but particularly about performance. A lot of times, I think that problems that feel impossible are only impossible because we have created in our minds requirements that don't really exist. What we feel sometimes when I explain the story, sometimes you feel, oh, but he kind of cheated. But why? I think that as software engineers, we are sometimes very wary of unconventional solutions, particularly of data solutions that, like the normalizing, like cold storage. But we shouldn't be. We should be bold. We serve product in a way. We need to fulfill those requirements. How we do it is our problem. Moreover, you need to think that software engineering, and particularly performance work, is about trade-offs. There is no such a thing as a perfect system. There is not a system that is everything is incredibly normalized, everything is incredibly performant, and everything works well. There is only a system that fits the current needs. Moreover, I believe that an excessive pursuit of perfection can be counterproductive eventually. But the good thing is that in this community, in the Ruby community, we know this pretty well. I mean, we literally are the one community that optimizes for developer happiness. Just take this quote from Matt. I believe that the purpose of life is, at least in part, to be happy. Based on this belief, Ruby is designed to make programming not only easy, but also fun. So, have fun.
Any questions?
You mentioned not to assume that the database chooses the right index. So how do you make sure it does?
You can check, like, you can try to explain, for example. Oh, yes. Yes. You can check when you run a query. There's well, I forgot now at this point, but I think you can run explain, and it will tell you exactly which index is going to be using. Actually, you can invoke it from Rails at this point now. I think there's a method. So.
Okay, thanks.
About this, there's been a back and forth with Active Record and these methods. Like, it is something that changes almost every version. There was a way to force an index, but I think it's not there anymore. I don't remember right now, but it's an interesting point of contention that nobody thinks when we think about Active Record, but it's there.
I have a question. You mentioned about the limits, product limits.
Yes.
Like, as a developer, I never thinking about this. Like, could you give some examples, maybe the limit you impose that were useful? Thanks.
So, well, for example, I mean, actually, product limits has. Let's talk first about limiting in general. Is it a good idea to set a timeout on a database? I would say yes, but that's a limit already. You're saying, hey, a query that is spent more than 1 minute, kill it, because it can have consequences. So this is how we start with limits. Then product limits can be things like, I mean, I will give an example at Zendesk. We have something called triggers that every time that you change a ticket, you can say, hey, if the comment includes the word urgent, send an email to the CEO, for example. This obviously adds latency to each ticket save. If you don't put a limit there, you may end up with people putting infinite amount of stuff in the process. For example, and you can do very crazy stuff with that. You can ask the trigger to parse a whole lot of text. You may end up, if you don't put a limit there, you may end up with, I don't know, very crazy logic being executed on each ticket safe. One other example of probe limit, and now I don't remember now, but limiting the access to endpoints.
Hi, I have a question about this cold storage for archived tickets. What kind of service or database do you use for this?
Yeah, I think I commented that, but a good question, because actually people ask me about this. We originally use React, not React, the JavaScript framework, but the memory storage, and now we're using DynamoDB in like AWS. Yeah, DynamoDB. Yeah, we use that for the storage.
Hello, shameless plug. Tomorrow I'll explain how to use explains in database and how to pick indexes. But first of all, I wanted to ask you, how do you guys do sharding? Do you do any kind of advanced things like geographically aware sharding, or maybe different kind of tiered sharding systems, or just regular table of tables?
Actually, that's a very good question. I cannot give you a lot of specifics. There's to a certain point, we do have some geographical sharding, but we don't need to be super specific, more like continent. I know that Facebook, for example, probably is sharding to almost a city or something, but we don't need that really. Then we do that in a, let's say, automated way, except if there are exceptions. For example, we had a very, very, very popular ride-sharing company that you use us as a customer support. For them, they had their own shard. So it's automatized until it isn't, let's say. And yeah, we don't take much into account. The most obvious things are regional, but we have a couple of pods that are in. Well, actually, for shards, we don't check geographies. We have, on top of the shards, we have pods. So a pod has many shards. But then we only care, for example, to have a couple of pods in Europe. I think we have a couple of pods in Asia and the rest in the US.
Hi, great talk. One question. You mentioned at some point that at certain scale, you not really have control over what users are doing with, what users are basically storing in your service. Do you have any sort of automated tooling for detecting whether your users are abusing your service and storing the data in Zendesk that shouldn't be here, or I don't know, they're using it as like a cheap or free file storage or something? Do you have any automated tools to detect this sort of abusive behavior?
That's a good question. I honestly don't know. A lot of things I detect is just because I run queries around. Like, for example, we found the other day that the account with the most tickets at Zendesk happens to have one agent. That's okay. I know that we have some, like we have abuse teams that they check this kind of stuff, but I don't think we have anything automatized. We do have, I mean, that's why the problem limit is so good. Because automatically, if you pass the problem limit, something breaks in your account, and you need to tell us. That's why I also believe in problem limits that are very crazy, that are very high, but eventually we control that nobody's crossing them.
Any questions?
Hi. So you mentioned about many techniques that can be used to actually address the issues that you encountered. Is there anything you would recommend to design for scale, to the practices that you wish you would have started with before to avoid the problems that you encountered when the system scaled?
Yeah. For me, one thing that is super important is that you need to scale on demand a bit. It's very different a startup that you may never be used and you need to pivot all the time than now at Zendesk when we write a microservice that we know day one, this is going to have 100,000 requests per second. It's incredibly different use cases. From here, things that I think that is very important to have in any case, and because they are very cheap to do in a way, is product limits, or I honestly believe it. The other, I think that having a clear idea on the data life is good. For example, I talk a lot about this table that has trillions of objects. That is right now is 40% of our total storage in relational database. I think we made a few numbers, and this thing is costing us millions of dollars. The irony of this is that we are not using cold storage on that because when we designed the cold storage, we just forgot. I mean, I am not sure about the whole story, but because it happened a lot of times, they were different engineers. But the impression I have is that people didn't know much about that table, and they just didn't take it into account. So yeah, having a very clear idea that all this data, how big is my data, and what I'm going to do eventually with it, I think it's important.
Thank you.
All right, thank you.